On this episode of the podcast, I have with me Brent Keator. He is an expert at Primary Venture Partners, where he does a lot of advisory work. We're going to be talking about tech debt versus reengineering tools. And we're going to be talking about how do we measure that? Where do you invest? Does software last long enough for us to worry about this? And what about the cost involved in going back and addressing this versus reengineering the tool altogether? And we're going to talk a little bit about AI's impact and some of those tools that you have to evaluate along the way, and going to see how much we can cover with you, Brent, but I appreciate your time. Thank you.
Sure. Thanks for having me on the podcast.
Absolutely. All right. So this topic, I actually think it's becoming more and more relevant as we'll be talking about when it comes to tech debt and reengineering tools. So maybe let's define tech debt in your view, because I think I have a fairly view that tech debt does mean a common thing, but I think there's different views of what tech debt actually means. So let's just define that before we start.
Sure. I mean, I think from my standpoint, a lot of it has to do, it can be at different layers. So tech debt a lot of times can be within the code itself. There's refactoring that goes in, it's involved with the tech debt there. A lot of times there is a lot of reinventing when it comes to new services for different developments and platforms. And so people are just continuing to build without actually looking back on it to figure out where they can clean it up or where there's reusable components. Like ideally, a shared framework where people can use a lot of the same, and then the uniqueness and the customized portions of it would be in separate, potentially repos or services that interact with it. So you can consistently iterate on it. So there's a code element to it. And then there's tech debt related to the actual, some of the product stuff there. Keeping things around that are no longer needed just because there hasn't been the reinvestment of the effort to actually bring it to the next level. Right. And so you're just holding on to it because it could be a pet, something that somebody is used to having around, but it's just hanging there. But there's alternatives of whether it's open source or something cheaper or something just more innovative that's more self-service to use in replace of it. I see it in those main lights. There's other areas it can be focused on when it comes to tech debt, but it's something that I highly believe should be addressed on a regular basis.
Absolutely. And I appreciate that. And I guess if we were going to look at this issue of tech debt versus reengineering, let's actually talk about that reengineering component as well. Because I think a lot of people will hear tech debt and they'll hear reengineering tools and they'll be like, doesn't that where tech debt eventually gets you? I guess when you talk about reengineering tools in comparison to tech debt, what is the difference there?
Sometimes when you look at the re-engineering of tools themselves, you end up building for things that maybe you don't actually need, right? You're coming in, you're building things that are supplemental to what's already there without fully understanding the complete problem of what you're trying to do, right? If it comes, hey, there's a new service or opportunity here, let's build upon it. And so you're potentially building a new tool for it, or you're keeping something around that has a lot more functionality that's not necessarily needed, but could be useful in that one use case. And so you're re-engineering some of the tools, whether they're in-house or customizing something from that you are doing from a third party in order to make your service potentially run better or more efficient or whatever the goal is you're trying to accomplish there.
Absolutely. I guess when you are thinking about software is written at a point in time. And at some point, there might be an issue with it, but there might not be an issue with it, right? I think it could be either way. It could be a perfectly good piece of software that just lasts as it is, but maybe the business dynamics change, requirements change, and obviously what was written doesn't work for whatever reason. When we look back at that and we're trying to evaluate a piece of code, I think it's actually very hard. I think calling it tech debt is doing it a disservice, because going back and thinking about the circumstances, the business at the time, the technology options available, the expertise in those, all these different things. And then we look at it in hindsight and go, well, there were some bad choices made there. When you look at that, is it just a brutal way to look back at other people's choices?
That's a tough question. That's a great question. I think that maybe it just potentially has a bad connotation to it.
Yeah, it does.
Like that. And so, but I will say that anytime I look back on code or even emails I've written or even reviews, things I've written in the past, I always look back on it like, oh man, what was I thinking back then? Like there always is an evolution of looking at something. It can always be better. I mean, I think there's nothing that's perfect that's written today that'll be perfect from 5 years from now. And so tech debt, you're probably right, maybe isn't the best label because of the connotation, because people, it becomes easily a blame culture. I mean, even some of these tools out here there, like GitLab and others, where you can actually look at doing a blame on it to figure out who made that last commit or who did the commit there. And then everybody's like, oh man, what were they thinking? But at the moment, it was probably the best solution. Or potentially under the time circumstance of getting something fixed or out there because of other like external pressures needed to get done and maybe wasn't revisited back to make it a little more robust in that time of development. And so it's tough. It could be a bad connotation related to it for sure. But we have to look at these things that what we have today is not going to be the thing in the future. Like it's gonna evolve or go away. And I think about different languages that I've worked with. I remember, dating myself, being a big Perl guy for scripts, right? And it's like, oh, this is easy. But no, I can't even put that on my resume. It's like, it's not, nobody's going to relate to it. It's like, and same thing with like, as we look at Python, you have other languages like Carbon, Rust, other ones that are, coming up. And so, but at the moment, in the time when you've written it in some of these other ones, some have lasted the test of time because of other companies or other leaders that have really pushed it, like a Python where, it's still relevant and continues to evolve from there. And there's still some of the underlying ones that are more kernel based that are still relevant as well. And so but there is this like omen or just kind of overarching assumption or being of that these things that we write today potentially aren't going to be around tomorrow, and we can't hold on to these things like pets. And I see a lot of places and people too are like, oh, we wrote this, why would we change it? And so somebody that's a senior within like a development team, it's tough to go to them and say, hey, what you wrote 5 years ago isn't, we should really change it. It's just usually doesn't happen. So these things start to stay around longer than they necessarily need to be. But it could go into the how much do you spend the time to refactor versus actually build new? It's kind of like, that's always a big problem. Even when it comes to architecture and cloud, it's like usually people look for a big bang. You want to look at it. Where do you do cost savings, right? And people are like, oh, we can't figure out what we need to get rid of because we need to re-architect it. And it just stays at a stalemate because people aren't going to spend the whole time to re-architect the whole thing, right? The ideal solution is to iterate on it and work backwards or potentially forwards on it to figure out how you can change it along the way. And a lot of times people look at things like the tech debt and it's all or nothing. Like, hey, how do we fix this? There's tons of places you can actually refactor it. But if you keep up with it along the way, if you're looking at it, there's certain tools out there. I'm trying to think of one. There's one linear B, I think it was, and it tells you a certain percentage of the refactoring that you've done. And so it looks at, there's probably maybe not the perfect measurements around it, but it's some sort of indicator of how much you're spending on tech debt versus net new code. So
absolutely, yeah, it's a hard one, and maybe the follow-up question to that is, anytime we have to go back and revisit something, there's a cost. And not only that, I mean, even if you wrote the code, you might not even remember the circumstances to even articulate if you're at the company, right? And heaven forbid all those people are gone and somebody else has to go look at it. I guess going back and looking at tech debt and reevaluating what is the ROI? What are we going to gain? And again, I know engineers love efficiency. They love elegance to solutions. They want to find an optimal way. To find that value, where does that line kind of sit? And again, I know this is a little general, so we're not picking a particular piece of code but generally speaking, there needs to be value for the company to go back to look at code in the past.
Yeah. I think if you can find data-driven elements within it, I think there's two parts to it. In general, if we're taking generally, like when I look at a roadmap, I try to map out 30 to 40% when I can of tech debt. It's a general bucket. It's something that we try to do to help with reevaluating what we have in the past and see if we can make it more efficient. But a lot of times you can tie it to something, right? You can look at it from something, maybe it's a cost efficiency, maybe it's a latency, maybe it's a, infrastructure sizing of what you have for handling volumes of data. There's elements that add value, and you can correlate it to, and hopefully you can correlate it to your product vision or the mission that you have for that particular sprint, quarter, or however you're operating from an agile sense, or waterfall for that matter. But I think you have to figure out exactly what the value add of addressing the refactoring or the tech debt, and it's not always as evident. And so it becomes, this is one of those things where it's hard when it comes to like a product roadmap, because a lot of times people are like, why would we do that? We can build these new features. Why are we going to touch this? It's not broken yet. And so let's wait till it's broken to fix it. And so I think that particular cost, whenever it's broken, becomes a lot more expensive, but it's not necessarily realized. And so it becomes a very hard paradigm to figure out exactly when to address it and build it in. But if you do it preemptively and say, hey, every sprint or every quarter, we're going to spend 30-40% on looking at old code and figuring out where we can refactor it. Maybe 30% is too much. Maybe it's all net new hard like software or development that you've done. So maybe it's a smaller percentage to start, right? I think there should be some element of where maybe it's even, I've been to places where it's like every other Friday, we dedicate somebody to kind of look at whether it's documentation or coding and it helps because it just gets another set of eyes on it to try to revisit it. But to your earlier comment, it's absolutely, I mean, even from week to week, it's only been like a few weeks. It's tough to know exactly what you're thinking at the time you're building it. Like you do so much on a daily basis as an engineer that just trying to revisit it is like opening a book and going, and getting off the subway in New York and then getting back on it and starting at that page again. You're like, where did I leave off? I don't even remember. You kind of have to get the context around it.
Yeah, I mean, it's interesting because I think sometimes if you were to consider other departments, I don't know if they have the same dynamics, right? If you're in accounting, the rules for accounting don't change. They do change, but they don't change that dynamically where you're going to go back, at some decision made 5 years ago to reevaluate how you would have re-envisioned it, right? And technology is evolving. And I think the challenge that I see is the point in time the decision's made, technology is X. The further away you go, obviously architectures might shift and there might be better ways of doing it. But for the organization, if the tool is still working and it's meeting the requirements, the gain needs to be understandably justified. And I know, again, going back, I know most software engineers like to write optimal code. It bugs them when they don't see that and they want to go back and fix it. When you're looking at this concept of refactoring tools and evaluating, let's say, a piece of tool that's been written now available that replaces some of the code that you've written, that also represents a complexity because you have to go back and potentially address a variety of other concerns. Is that almost as hard as dealing with tech debt when you are going to go back and refactor and integrate into a new tool?
Yeah, there has to definitely be an evaluation done on it. I think there's definitely different components that are part of it. One is, the time spent. Another is kind of the cost elements to it. And then the other is kind of the future, like forward progress you're going to have with it, right? If you can look at different open source solutions, but if it's been forked before you've gotten to it, or it's been 2 years before contribution, it may not be the best solution to replace an existing one, right? So there's a forward thinking that you can pay back those dividends of what the prices you're paying now that may render additional like rewards later, right? And so you want to stay focused on figuring out, is it worth replacing this? Some examples might be, when we're looking at different, because there's a lot of parity between different tools. I mean, like I can't think of many, if any, the one tool that's the only one out there that has monopoly on it, and that's the only one you can select for it, right? And everybody keeps each other honest with it. Even when it comes to cloud providers, there's some have personal preferences based on experience, but the services there run some level of parity. And some people like different aspects that are stronger than others. Could be documentation or just like support around it, or some of it's a little bit of the cost element there. And so I think it's you have to sit there and weigh it out and actually do some like back of the napkin or even spreadsheet type of math on it to figure exactly how much time does it take to get it off the ground. What's the cost that you're going to achieve? Is it going to be lower or higher? I usually try to go for the big three, right? It has to be better, faster, cheaper if you're going to make some sort of change. And so if you can't sit there and categorically figure out exactly at least two of those three, then it probably isn't the right solution to change a tool or re-engineer to use a different tool around it. The other thing is to always think, because there could be a heavy lift to get from one tool to the next. So as you're developing it, you should always think in an abstract layer around it, right? If you want to use something layer as a third party, you can't control exactly what they're going to do in the future. And they could spike their costs. They could do tons of things. But you can get yourself to an advantage from a negotiation standpoint if you build an abstraction to it. And so you can switch underneath the hood whatever tool you're using around it. It could be something as simple as, like a cloud native solution versus a third party. If it's like Dataproc and Databricks or something, if you have an abstraction to it, you have to evaluate the cost. Is it worth that time for development? But it could be. It could be worth it. And so you have that flexibility, especially when it comes to negotiations, as well as finding the best solution for what you're trying to accomplish there. And you could have both of them in theory, and then keep each other honest with it. And different parts of your company use different ones, and then you can maintain that one layer of abstraction around it. It's kind of like the shared frameworks. There is an overhead to maintaining them, but it helps because you can actually maintain it, and people are more aware, and your developers are more aware of what's going on because you're controlling it at that level. Whereas if you're kind of at the whims of a third party of any of the changes there if you don't have this extra layer of protection there. So I find that particularly important.
Interesting. I like that. I guess when we were kind of thinking about this topic, we were looking at also the ecosystem within engineering. Right? There's a lot more open source. There's a lot more build your own tool. There's a lot of different factors that go into it. If you're looking at open source as options, are there things that you have to factor differently when you're going back and re-envisioning these tools?
Yeah, I mean, you should look at it. You should look at the cost if it comes to like a licensed like third-party software versus open source. But I mean, like we were talking just a second ago about the contributions that are happening there. You could look at it from an ecosystem of where it sits. I mean, one tool that comes to mind is WireGuard is open source and at a beta level where I saw a lot of production use around it. But you could tell from what it was doing and the level of commitment around it and the contributions that it was something that had the support and the community wasn't going to let it down. And it still is alive and still people are using it for these extended bandwidths and like the commitment and continuity around it. The other ones, I mean, you have to sit there and look at it and see, who's contributing. Is it forked? Is it something that hasn't been like as relevant around it? And then the costs that come to it. The other side of it is kind of the security. It depends on your internal security and compliance around it. A lot of times there's third-party tools that do evaluations on open source, and it depends on some of the libraries and dependencies there. And so you have to kind of do a deeper dive into it if you're going for different compliances or other different compliances out there around using open source libraries and cross dependencies there. But the more like prevalent it's out there, and there's a lot of great open source tools out there that have a license model for support as well. Like NetBox is one of them, like Grafana Cloud. I mean, there's tons of them that they've unleashed it to the community of open source, and which is appealing to engineers, and not to have something that was built from a development sense, and then adopt it. And then if you need additional licenses or functionality or even support, that there is a paid option as you continue to grow to help give back and contribute back to these particular solutions.
Interesting. You'd mentioned obviously AI and its role within this conversation, and I could imagine there's a few directions this could go. But I'd love to get your thoughts of when it comes to software engineering. We're talking about tech debt. We're talking about potentially refactoring tools. Where you mentioned AI's impact, what does that look like? Has it started, or what are you seeing?
Yeah, I mean, it's starting. I mean, I think it's still a ways away from really maturing out. I think a lot of it is still the buzziness around it, and people want to bring it in and be a part of it, even for like a VC funding perspective, to include it into the portfolio and direction that you're going. I do think there's elements where you have to look at efficiencies. Like you said earlier, engineers are all they're a lot about building efficiency around it. And there's AI components, whether it's third party or something you're going to try to build in-house around it. It could be something like that the LMs are trying to do something from a chat or support functionality. But I think there's also the bigger endeavors that I see companies going on. And some of it is like there's one that comes to mind is kind of I've seen companies where you have dedicated teams that do data analytics around it, and they look more of kind of a data democratization model, right? So you have all this data that's coexisting within some sort of tool or location. And if you have something that can mine it better and make it more conversational for access to be able to get things done faster, there's exploration there. But it's dangerous because you have this data that's going out in a very easy fashion, and it could be misinterpreted if you don't have all the safeguards in place or a level of analytics to consult with to make sure that what you're basing your decision on is actually accurate. So I think there's still maturity around the safeguards to make sure that these things are accurate. It's like double checking your test after you've taken it. You think it's right, but there might be a few that you miss, but if you reread the instructions, maybe you get there, right? And so I think there's still some time around it before it becomes maybe there's a confidence interval that should be there. This is the result, but we're 50 to 60% sure, so you should really double check it. But a lot of times people take it as fact and take the decisions on it without like mining that particular aspect of it. But I think we're starting to see more and more, and even in like tools, all these tools out there when it comes to third parties, they're all coming up with their own AI component. I mean, there's so much stuff on LinkedIn and other like platforms about, which one's better, Copilot, or all these different ones, ChatGPT. And I see developers using this constantly. I see, and it's good. It helps enhance, but you have to have the baseline foundation to be able to understand what you're doing, right? I've done through helping with security patches on a language I was less familiar with. And I was like, let me just put this error into these like a ChatGPT or Copilot and try to figure out exactly what's going on and try to understand it. And it gives you like an affirmative, confident answer. But if you try to apply it and something else breaks, you're down like a really bad rabbit, like a path that you have to try to fix and figure out how to work it backwards. And so the foundation has to be there to be able to build upon it. But we're getting there. We're getting closer, and we're learning from it. The dangerous element around it is how do we manage, and this is kind of more broad, is how do we manage learning from learned information and learned data? We'll potentially at some point start to lower the amount of unique data that we're interpreting that's not already modeled or learned from elsewhere. And so it's a bigger problem to solve. But I think that getting the confidence and accuracy around the data that we have when it comes to things like a data democratization effort and getting us the trust tools from the experience with a level of interval, I think we're going to get closer and closer there and figure out what the offsets we do around whenever we're bringing in some tool that may supplement or offset is something we're doing like a chat functionality within support where it's learned from all the historical data to build upon it. The other element I'll say is that I see a lot more people using your kind of Slack or IRC or Teams or something of that nature. I think people are building in that functionality where there is a level of understanding all that data to be able to give it in a more like NLP or language, like conversational language element. So even internal communication of tools as well as external. So seeing a broader build on that.
Interesting. I want to tie this back to our discussion around tech debt. If the future is going to be some help via AI, whatever that's going to be, right? Obviously, maybe some code being written, maybe entire applications, I don't know. And I get this is your look in the future goggles, so we're not going to hold you to it. But tech debt and the notion of we're going to go back and look at the business requirements that have changed or the efficiency of the code or whatever it is about tech debt, it's going to be more of a black box. Or is it just going to be code has always been disposable and we just have to get comfortable with the fact that it costs X to go back and address business requirements? I guess is AI and helping us write code, is that going to move the needle for tech debt?
I don't think so. I think it'll help. It'll help, but it's not going to move the needle on it drastically, right? I mean, I think we have to get comfortable, to your point, we have to get comfortable that what we write today is going to be gone, quote unquote, tomorrow, right? We're replacing it. Whether we use another tool to do it, maybe we use it and we get there, but then maybe you have less people to understand it as well because somebody else wrote it that's no longer there, right? Or it became a system that wrote it, and once it got functional, people didn't look as deeply into it. I think there is probably a lot more in we probably don't have time to touch on discussion of like the testing and the shift right and then left trying to figure out exactly what our solution is, and making sure that we're doing maybe even test-driven development around it to understand exactly what we're building, as opposed to delivering on what the product requirements were. And so we have some of these potential safeguards in place to make sure that we have these checks and balances to help with how we're addressing some of the tech debt. But I think the AI helps get you to a certain place, but I don't think it gets rid of the notion that you're going to replace what you've written today at some point.
All right. Yeah, we definitely can revisit the notion of what happens to AI in testing and a lot of different aspects, maybe in a different episode. Brent, it was really great having you on. Thank you for taking the time to share your thoughts. How can someone get in touch with you if they want to pick your brain on something you mentioned?
Sure. No, I appreciate you inviting me on. This has been a fantastic conversation. Always welcome to come back and for more conversations. But at LinkedIn, I think probably within this podcast somewhere you can see my LinkedIn address or email should be available. Feel free to reach out to me. I'm happy to talk more on any of these things that I have. These are things I enjoy conversing on, or even discussing, or even being objective on any of this stuff. So I appreciate it.
Absolutely. All right. That's it for this episode. Be back again, different guest, different topic. Until then, two things. One, I think Brent covered a lot of ground when we were talking about tech debt, talking about refactoring tools. We talked about a little bit of open source, some AI's impact on this process. And I think Brent dove in pretty deep in terms of some of those factors of when to look at refactoring, when to go back and address your tech debt, and what do they each mean when we're looking backwards. I think it's really a difficult conversation because it's really just hard. No one's dealt with it yet. So I think Brent's opinions and views were fantastic. And please share this episode with somebody else. I'd love to get the conversation going. I think he addressed a few concepts that I think would be good for others to take a look at as well. Also, like, subscribe, comment. Let me know how the show's going for you. Until next time, thank you and goodbye.